All right, hi, I'm Louis Tribble. I'm the lead machine learning engineer at Save-A-Lot. Today I'll be presenting a strategic approach for Save-A-Lot to counter revenue loss by expanding our store network through banner flips, leveraging the power of AI. So a little bit about Save-A-Lot. Most of our 700 plus stores are owned by retail partners. These are individuals or organizations that own and operate one or more stores. Our largest retail partner has over 100 stores. Our discount grocery model enables our stores to compete on value and convenience with limited and localized product assortment. Since we don't own the stores, our revenue comes from wholesale distribution to the stores. Save-A-Lot has faced a significant challenge over the past 5 years, going from 971 stores to 736. That's a 25% drop, with revenue falling at a comparable rate. I would point out that most of this attrition is due to mismanagement by retail partners and not a problem with our business model. So to solve this problem, our business development team is focusing on banner flips, and that's converting competitor stores to Save-A-Lot stores. This is a fast, cost-effective way to grow our store network as opposed to building new stores. The problem for our business development team is finding the right competitor stores to flip. They're working with a very large data set, which they purchased from a vendor, using primitive tools. I mean, Excel has improved, but it's still 30-year-old tech. The competitor store data set has many key attributes, but to really understand if a store is a promising banner flip opportunity, well, that requires hours of painstaking research. So the banner flip engine solves these problems by allowing the business development team to easily interact with the competitor store dataset and create in-depth research reports in minutes rather than days. So the entry point to the application is a React agent that interacts with the user and calls tools depending on the question. If the user asks about store information, it calls the SQL agent. The SQL agent is initialized at startup. A SQLite in-memory database is created, and competitor store data from a CSV file is loaded into a table. When it's invoked, it analyzes the user input, generates appropriate SQL, executes the SQL against the database, and outputs the formatted results. If the user asks for research for a store, it calls the store research chain. So this chain starts by invoking the SQL agent to get all store attributes from the database. And these details are input to the deep research graph, which has been customized with domain-specific prompt instructions, section topics, and data sources. And the resulting report provides the right information analysis for the business development team to determine whether the store is a promising banner flip opportunity. So let's take a look at it. All right, so here's the app running on Hugging Face. Let's start with a request for some store data. So show me all stores within 100 miles of Winchester Distribution Center, sorted by distance. So this request is fundamental to competitor stores' viability. If they're too far away from our distribution centers, transportation costs will negate the store's profitability. So we'll run that, and we get a nice table. Right now, limited to 10 results just for efficiency reasons. So let's ask for store data another way. Let's find independent stores within 20 miles of Fort Lauderdale. So this kind of exploration is important if the business is looking to expand in specific locations. This also uses a custom distance function which geocodes Fort Lauderdale and computes the distance using latitude and longitude. So here's 10 of them, and we see there's this Howard's Market in Boca Raton. So let's ask it to research that for us. So we get a comprehensive report including demographics and economics, competitive analysis, visibility and accessibility, physical assessment, owner information, which is critical about who do we need to contact if we want to pursue this, financial viability, and finally conclusion and recommendations, where this is telling us that Howard's Market is well suited for transition to Save-A-Lot. So yeah, so exciting stuff. And let's see. So looking ahead, some features I have in mind. I'm currently using public data sources to limit costs. I want to add paid API services that provide more complete and accurate company information. I also want to create a research library of completed store reports and build a RAG agent that, on top of that, that enables summarization, store comparison, prioritization, that kind of thing. And also, with help from marketing, I'd like to create a public-facing version of this that allows interested competitors to get a personalized report based on the information they provide about their store or stores, on the benefits of switching to Save-A-Lot. And that's the end of my presentation.